Welcome, agents, to Mission Impossible Exam Extraction. I am your lead strategist, and today we are targeting the Cambridge IGCSE Physics exam, specifically Syllabus 0625 alongside its sister papers. Your mission, should you choose to accept it, is to extract maximum marks from a highly hostile exam paper in record time. We've monitored two typical recruits in the field. First, we have Alex. Alex overloads on raw physics facts, dumping every equation onto the page with zero analysis, leaving easy marks behind. Then there's Sam. Sam rushes the paper, completely missing the crucial command words hidden in the questions, and loses marks despite knowing the science. Look at their past papers side by side, covered in red pen. We are going to change that. Today, we are taking the complete Cambridge physics equation list and transforming it into a tactical, structured blueprint. We're turning a chaotic wall of formulas into an organized arsenal, so you never freeze under pressure again.
To execute this extraction smoothly, we have divided our briefing into 5 distinct operational domains. We will sweep through mechanics and forces, extract the intel on energy and power, navigate the fluid dynamics of pressure and waves, decode core electrical circuits, and finally, scale up our operations to the physics of the cosmos.
Domain number 1. We start our briefing with the fundamental rules of how objects move and interact with one another in physical space. This is the bedrock of classical physics, and it's where exam papers love to test your baseline accuracy.
Let's scan our primary data. Speed is simply distance over time. Right next to it, acceleration tracks the change in that velocity over time. And moving along, we define the very substance of objects. Density, which is mass divided by volume, and gravity, which links weight to mass. Now, this is exactly where recruits like Sam rush and fail. They see a simple kinematics question and immediately plug in numbers without looking at the command word. If the paper says calculate, sure, run the numbers. But if it says describe or explain using these formulas, dumping raw numbers will get you that dreaded red pen. You have to understand what these baseline properties actually represent in the physical world.
Now we are entering strategy territory. Look at how these concepts build sequentially. We start with Newton's classic. Force equals mass times acceleration. Then we calculate moving mass, giving us momentum. Apply a force over a specific time, and you get an impulse, which changes that momentum. Ultimately, this lets us define force as the rate of change in momentum. To extract top marks here, we deploy the Peel framework. Point, evidence, explanation, link. Top-tier students structure their answers by first making their point, then providing these exact formulas as evidence, explaining the physical relationship, and linking it back to the specific exam question. If a question asks why a car crash is lethal, your evidence is force equals the change in momentum over time. Your explanation is that a shorter collision time drastically increases the force. Do you see how that works?
To close out our mechanics intel, keep in mind how force is applied to stretch springs or create rotational moments. For springs, the constant K equals force divided by extension. For moments, it's force times the perpendicular distance from the pivot. Master these, and mechanics becomes a breeze. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. You need the strategic intel flowing to your feed every week if you want to secure those top grades. Moving to our next sector, let's initiate Phase 3, the transformation. We are going to decode the formulas dictating how energy is transferred, converted, and utilized, and watch how applying them correctly transforms red marks into green check marks.
What's really interesting here is how kinetic energy, potential energy, and mechanical work are totally interconnected forms of energy transfer. Kinetic energy relies on mass and velocity squared. Potential energy relies on mass, gravity, and height. But work is simply a change in energy. Let's do a live rewrite of one of Alex's failed answers. The question asks to calculate the final speed of a falling object. Alex just wrote down the kinetic energy formula and got stuck. But if we guide Alex to set the loss in potential energy exactly equal to the gain in kinetic energy, suddenly the mass cancels out, the equation solves itself, and those red marks turn bright green. That is the power of the physics success blueprint.
Here is a prime example of an exam trap designed to test your situational awareness. You can extract your efficiency percentage using either total energy or total power, depending entirely on the intel you're given. It's useful output divided by total input multiplied by 100. Examiners love to mix this up. They will give you power values when you are primed to look for energy values. Don't let the hostile paper trick you. The structural relationship is exactly the same, so adapt your strategy to the data provided. Ultimately, power is simply the rate of work done or energy transferred over time. Whether you divide the mechanical work by time or the total change in energy by time, you arrive at power. It's asking a highly tactical question. How fast is this system spending its energy reserves? Understanding this is crucial for the time management matrix of your exam strategy. We are now entering our interactive workshop phase. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's plunge into the dynamic realms of pressure, heat, and wave mechanics. Welcome to challenge number 1, data scan. Imagine a 60-second timer is ticking down right now. You are presented with a complex data table comparing solid block pressure and underwater pressure. What's the core trend? Basic pressure relies on force over an area, but fluid pressure requires density, gravity, and depth. If you are analyzing a submarine hull, you don't use force over area. You extract the fluid density, the gravity, and the depth change. Your 60 seconds are up. Did you spot the correct formula to deploy? Now for challenge 2, find the flaw. I am showing you a sample physics paragraph about gas laws. The student has flawlessly calculated the pressure and volume, but the examiner gave them 0 marks for the final calculation. Can you identify the flaw? The student left the temperature in degrees Celsius. This single magic number, 273, is your ultimate conversion key. You must shift temperatures into the Kelvin scale before applying gas laws. Forget this number and your mission fails instantly.
Following up on that, remember that pressure times volume is a constant for a fixed mass of gas at a constant temperature. And then we have specific heat capacity. This links energy to mass and temperature change. When the exam asks you to explain why water is used in cooling systems, you don't just say, it stays cool. You use the Peel framework. Your point is water's high thermal capacity. Your evidence is this exact formula. Your explanation is that it requires a massive change in energy to alter its temperature. That is how you guarantee maximum marks.
Time for challenge 3, speed writing. You have a 30-second timer in your head. Write 1 perfect Peel paragraph explaining how light behaves when entering a denser medium. Go. Wave speed is frequency times wavelength. Refractive index gives us 2 paths, sign of incidence over sign of refraction or 1 over the sign of the critical angle. Your paragraph needs to link the slowing wave speed to the refractive index calculation. Time's up. If you led with the formula as your evidence and linked it to the bending of the light ray, you just secured full marks. Phase 4 equips you to tackle the invisible, highly structured world of electrical circuits. This is where the paper gets especially tricky, but if you treat it as a logical grid, you can't be stopped. Watch how these properties build on one another. First, current is the rate of flow of charge divided by time. Step 2, we elevate to voltage, which is the work done per unit charge. Finally, resistance is simply voltage divided by current. If a 6-mark question asks you to design an experiment to find resistance, do not panic. State your aim, list your voltmeter and ammeter as your tools, and explicitly write down R equals V over I as your analytical framework. Look at these circuit combinations. Power equals current times voltage. But we can also write power as current squared times resistance. Energy is power times time, giving us IVT. And we have this incredibly simple ratio for potential dividers. Resistance ratio equals voltage ratio. When Alex takes this exam, he tries to calculate every single variable from scratch. Don't be Alex. Use these proportional relationships to bypass the heavy math and extract the answer in half the time. When interrogating transformers, remember your command words. If they say calculate, use these rules. The voltage ratio between primary and secondary coils exactly matches the ratio of the number of turns. And, assuming perfect efficiency, power in equals power out. But if the command word is explain how a transformer works, you have to talk about alternating currents and changing magnetic fields. The equations alone won't save you if you misread the mission objective. We have reached Act 5, the final system. For our last directive, we are scaling our toolkit all the way up to the mechanics of the cosmos. Here we map out the math of the universe. Orbital speed is the orbit's circumference divided by the orbital period. And Hubble's constant is the recession velocity of a galaxy divided by its distance. Let's look at the progress bar of our physics success blueprint. To reach 100% mark potential, you need 3 rules. Rule 1, command word decoding. Always know if you are calculating, describing, or explaining. Rule 2, PEL framework application. Structure your thoughts. Rule 3, time management matrix. Don't spend 10 minutes on a 2-mark Hubble constant question. Inverse the constant to find the age of the universe, write it down, and extract yourself from the question. You now have a complete, highly organized arsenal to conquer your Cambridge exams. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainer sessions. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @theexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.